a little bit about myself and my credibility to talk about this topic. I've been with Microsoft about 13 years, starting in MSR as a research intern and then returning as FTE. I've been in different roles: software engineer, data engineer, data scientist, data science lead, and more recently I am in applied AI engineer role in the team called customer advisory. So in this team, we prototype solutions for the customers using the either recently released or even not officially released Azure Data products and Gen AI. And also another part of my role is building learning materials and guidance for the customers. And for internal Microsoft, I'm co-leading the community of ML professionals and enthusiasts. It's about 22,000 people from across Microsoft, so I'm doing something similar to what Greg is doing, but within the company. And my alter ego is a watercolor artist, so a lot of you, I suppose, in Oregon are into hiking. My hiking is with a set of paints and paper. So this is what pandemic brought to me as a gift.
Those are some beautiful watercolor paintings, I want to say.
Thank you.
Like,
Thank
you are
you.
talented.
Yes. All right. So RAG on Microsoft Fabric. This is a principal scheme of the work that we will be talking about today. So in the center is notebook that is running on Fabric platform, and obviously the data science language which we will be using is Python. The other important pieces of that include storage layer, for which we are going to be using Fabric Lakehouse. Because RAGs usually involve working with large data, I will also be demonstrating how you can use Spark for that. To be clear, the demo example today does not necessarily require Spark. It's small enough to be handled just by pandas, but in the interest of generalizability and showing you some unintuitive tricks which would be beneficial for you in the production world, I decided I'll go with this route. Azure OpenAI, which can come in two flavors. One is you probably know that with F64 capacity on Fabric, it's out of box. But you could also just use any Azure OpenAI GPT model that you already have and hook this into the notebook to build the RAG. And then an important part of RAG is the vector database. We will be using Azure AI Search here, but this, again, please take it without loss of generalizability. It can be something else. It can be, for example, Azure Cosmos DB or some open source flavor database. My general prerequisite for delivering content about modern Gen AI is do not get too hooked on the specific model or specific database. The truth today is like they just change so much that becoming an expert in one will not give you much of the advantage as it used to be like some decades ago, where people with the like thorough knowledge of some APIs could thrive, right? These days we need to focus on learning the building blocks for systems. And this knowledge about building blocks and ways of gluing them together into functional and performant systems that meet certain level of required quality characteristic and reliability. This is what really enables us to deliver powerful solutions. And specifically to Gen AI, the concept to embrace is how non-deterministic it is by design. So its huge power comes with similarly big trade-off. We need to appreciate that the fact that it can do certain things as good as or even better, at least in terms of speed, as humans, also means that just like humans, sometimes it fails on the same thing which it used to do very well before. And that, again, is something we can take into account when we engineer RAG. Okay. I'm seeing some questions in the chat. Is there anything? Oh, what RAG stands for? Yes, Retrieval-Augmented Generation, and I have it covered in the slide, actually, just not in the very first slide. So this octopus, by the way, is in Microsoft internal representation of Gen AI, and this is also my creation with the help of DALL-E. The concept I want to convey here is like, octopi, they are some of the smartest creatures on nature. They adopt, they can change colors, change shapes, and whatnot. And at the same time, they're insanely cute and they're not intimidating, right? So especially this one. So this is kind of the spirit of Gen AI learning. It's advanced, but it's fun and interesting. Okay, so the material of the first part of today's talk is actually open sourced. So if you're interested, you will be able to get the notebooks, deploy them on your Fabric capacity, and run. I do not recommend that you do it right now because it will distract you from the presentation, but the learning path here is building RAG, evaluating RAG, and optimizing RAG by trying out different types of search or trying out different types of underlying GPT model. So this is something that should give you a very quick start with any scenario. Specifically, what we will be talking about today is a demo with quite common case of knowledge base set of articles. We used an open source data set from Carnegie Mellon that is based on a snapshot of Wikipedia, including several articles about geography and nature. The data was augmented by students of Carnegie Mellon with questions and answers grounded on information within those articles. And this also has levels of complexity, easy and hard, and medium. Even though it's very simple data set, it captures very well the average type of knowledge base for RAG, and the more complex cases kind of build on that. We will be talking about this too. So RAG, as Retrieval-Augmented Generation, is a powerful approach of using Gen AI. And from the human world, I would suggest that you use the metaphor of a librarian, right? Librarian is usually a well educated persona with good logical skills and good abilities to search content per request of readers within a well-structured library of books and journals and whatnot. So RAG is also, unlike a model that has been fine-tuned to understand a particular domain, it is a general purpose large language models that is augmented with a set of materials which are from a particular domain or a set of domains, like, let's say, medicine or maybe commerce. And this material is being preprocessed, structured in a way that makes it easy for the system to fetch and then to process in order to provide a well formulated response back to the user, along with references to the original sources. So this is the main idea of RAG. The schema of how, like at high level, the system performs looks like this. In the beginning, there is something that triggers the system action. That usually is a question coming from the user. Question is sent to a block which is highlighted here as a retrieval function. So the purpose here is to get materials which will help the generalist answer those questions. And materials can be, in the simplest case, picked up from a database, but this may also be API to some system, like ServiceNow is probably a familiar system for many of you, or think about search APIs, or maybe like shares, stock quotations APIs. So different possibilities exist. Then we send the user question, the materials which were found as relevant to this question, and the prompt explaining the language model what we want out of it. And this may include, for example, things like about structure of the response, about the style of the response, and then it is sent to the model, and then the output is sent back to the user. So at high level, this is how this works. Now a little bit more about the underlying components. So the retrieval piece, which is core to successful performance of RAG, is in many cases reliant on a pre-built database. And to facilitate very fast retrieval of information from there, the search is not limited to just keywords, but also supporting the popular mathematical approach of embeddings, semantic embeddings. So you can think about like words and phrases being represented as array of numbers. And what you likely have heard before, the reason why it works is that similar words and similar phrases end up being embedded closer to each other than the ones that are different, as depicted here. And also the math of vectors work there. So if you like add a vector representing a woman to a vector representing a king, you will end up having a queen, right? So this is how, like, at high level it works. And so semantic search plus search by keywords together, they give this very powerful retrieval capability. Okay. And vector and index databases is how it works behind the, like, it's in its core, it's just good old database, except that it has like support for those embeddings. So it has algorithms that allow faster search over the fields of vectors than just generic database, and sometimes they also have specialized API, but in its core, it's still just good old database. And now that we know the concepts, let's look at the system in its whole, right? Like before that, I only covered the runtime part of it. But for this thing to work, obviously, we need things to be in the database. So before RAG goes to the users, first you need to populate the knowledge base with the content to support it. So we take the documents, we divide them into fragments that are optimized for retrieval. We then calculate those vector representations for each of the document chunk, and we ingest them into the database. So here is a vector database, and then an additional component, which was not in the previous representation, is that for user query, we also calculate embedding. And when we want to find relevant content, we do similarity search, not just keyword search, but something that is close to it as a vector. And I see there's a question from
Hi.
Amon.
Yeah. Can you hear me, Alexandra?
Yeah.
So is the assumption or the situation is that the LLM it's like an API call. You can't modify it. You have no ability to change the LLM. So that's why you have to do this bulking up of the search prompt outside of the system. If the LLM were like an open source LLM, then you could have the LLM do this, because this vector database you're building, it's not specific to like the instance of the query. It doesn't have any information about the user, the content. Is that right? It's not like, because I thought initially, and this is all new to me, but I thought that it would like pull in context about the user and I don't know, information in the user's profile, something that wouldn't already be built into the model. But if we're taking words and we're like building what I forget what these vector databases, in theory that could be part of the LLM and how it operates.
Yep, that's actually a really good question. There is more to it. So for one thing, what you are talking about, like user's profile, it can totally be part of the context which we send to LLM. And in the more advanced version of it, towards second and third part of my presentation, I'll be explaining that too. But that's not the biggest reason why it is this way, why we have this vector database. There are two things. One is, as you know, probably LLMs are very expensive to train, right? So even fine-tuning itself, it does take substantial amount of GPU power and therefore monies. And even in a pretty stable domain, you are never done, right? You always will need to update the information, because things that are captured in encyclopedias, they certainly are the most stable, but the business cases for RAG, they are usually much more dependent on the changing world. Say, like the simplest one would be a RAG that helps employee navigate internal corporate resources about getting vacations, paying taxes, promotions, and whatnot, right? This is not stable. Maybe it doesn't change every day, but there are articles which would be changing maybe every couple of weeks or every month at least, and there are things that are dependent on geography. When you rely on a well-structured, transparent information that is captured in the knowledge base, for one thing, it is much cheaper to keep up to date, and for the other, it is also much more reliable because transparency of the knowledge within the language model is very limited. It's in the end, it's the weights connecting layers of the neural network. And so like you give an employee some response about like, hey, like you can take a certain number of days of vacation per year as paid leave, right? If it just comes of a fine-tuned LLM, you cannot provide the source. If it comes from a RAG, you can give them back a link to the resource on the corporate portal where it came from. And so they can also go and verify it, because sometimes like LLM may read it, but say something wrong back, but the human in the loop has the opportunity to go and double check the correctness of the information. So in terms of responsible AI, this is also a very big deal.
Thank you so much.
Yeah. Okay, and chunking. So chunking is a big part of building RAG, and let's go back to the library analogy. You may say like, hey, models can take really huge pieces of information now, like officially thousands of tokens are depending on like concrete endpoints, but thousands of tokens can fit the context window. So why chunk, right? There are several reasons. First is, like humans, LLMs work better when you give it smaller information. Second is when you break information into chunks, it's easier to navigate. So again, like it's like a book. Instead of parchments in the old ages, which is an equivalent of like long raw text, you end up with book broken down by pages and potentially by chapters, making it both semantically and physically easier to deal with when you're looking for a particular piece of information. And there are different chunking strategies, which we can talk about in more details. Okay, so I covered the theoretical 101 part, and my next thing is to show you a notebook, unless there are some questions before we continue.
It's very well explained, honestly. So thank you for kind of covering the groundwork.
Awesome. Well, all right, so I'm about to switch to my fabric, and I think in the interest of time, I will not be running the whole notebook live. It's working. To prove that, I literally did a fresh run for your benefit this morning. I'll probably just walk through it, and I'll run some interesting pieces. So this notebook is like your getting started kind of framework, potentially, if you want to build a RAG. And the components of it, like I said, are Fabric. In this one, I'll be using the pre-built model and Azure AI Search as the vector DB, but you can replace it with other things. So this is where you would populate Azure AI Search credentials. You do not necessarily have to have paid one. You could just create a free tier. It's explained also how you get this to work. And then in this part, we do some imports. Important thing to keep in mind, I did mention in the beginning that current world of open source and general technology is very dynamic, and a lot of interfaces change literally every day. So the way to accomplish some level of stability, of course not perfect, but at least some reasonable level of stability, is to freeze the versions which you're using. With Fabric, you can accomplish this by building a custom environment. So here, my environment is called Fabric Rag Samples Synapse, and it's fixed at specific version of Spark Compute. And I also have a pre-built configuration of the packages, custom libraries here, built-in libraries. So this helps me have decent level of confidence that even if somebody releases a new version of the dependency package, my notebook will still be running, and it will be of no concern. So what I'm doing in this notebook is, first I'm getting the data, and like I said, this is open source data, so you can get this data too. My data is already in the lakehouse, and here I'm showing you how I'm reading it. It's good to get like visual glance of it before you go further, because it helps you to like understand what you're dealing with. So here, text of the knowledge base is something of this kind. Pretty lengthy for human, not so lengthy for LLM. However, we will be breaking it down into chunks. And like I said, the good part which we like about this data set is that it contains not only data for RAG, but also a set of questions and answers, which we then can use for benchmarking the performance. And we'll talk about performance evaluation in just a little bit. So in the beginning, we are doing chunking. Don't overthink the code right now. This is just some basic approach, giving the length of the chunks. And this also gives out the output of chunking. What you want to know to deal with Spark is that Spark is lazy. Spark is a little bit like some humans who don't do stuff until they actually need to present some evidence that this stuff is working. So you might be surprised how it takes just 13 seconds to do something that requires compute. The truth is, it only does it on, like here I'm enforcing augmentation of the data set with IDs. It will only augment 103 rows because I asked it to display, and the display is limited to 103 rows. Only once we ask Spark to do some action that requires you to go through the whole data set, at that point it will complete the work. So here I have a function of embedding. I'm using an OpenAI endpoint that comes together with Fabric capacity. I'm telling it to use some particular model of embedding, and I'm telling it to put to put the result of embedding into output column called embedding. So this is how it looks. Just an array of floating point numbers. Now, when we have created embeddings, we want to ingest it to the vector database. And like we discussed, in our case, it's Azure AI Search. It's not super important. Again, if you're interested to learn about the configuration more, feel free to go to the repo. I'll share the link later. It explains like why it's configured in certain ways and how else it can be configured, but that's not critical. We basically have some vector database here. And then we have a function which is in the format of something specific to Spark, user-defined function. The reason it's important for us to define user-defined function is because it is compatible with Spark, and a function in this format, equipped with this attribute UDF, it can be applied in a distributed fashion to our data set. So within this function, we are basically telling that we want to put instance of data inside Azure AI Search with a given endpoint, and we explain the configuration and how success and failure are defined. So that's pretty much it. And yeah, so this is where we apply this function and just to AI search. And this is the parameters which we're giving to it, the names of the columns in our data frame. And this is the important point. Like I mentioned to you, Spark is lazy unless we tell it to go over the whole data set in some way. It won't do that. We are asking it to go over the whole data set and report how many of successful ingestion for each row it had and how many not successful. So here we saw that successful uploads are 172, unsuccessful uploads are 0. At this point, if I go on Azure portal and look at my Azure AI Search, I will see 172 entries. If I did so before looking at successful and unsuccessful uploads over the whole data set, like if I executed it here, I would see only 76 entries in the search, right? Because that's what it would actually do. It pretends that it has completed this row, but as you see, it took only 2 minutes to do so compared to 3 minutes, 53 seconds. It's not logical, right? Like all we do in this block of code is count success and not success. It should be faster, but because Spark it's lazy, this is how it works. So I really want to bring this to your attention because it's unintuitive and we tend to forget about that. Okay, so and here we got to the point where we have built RAG, right? And we just need to put it all together. So we have now a function where we do get context source. The function is actually retriever component, which talks to our vector database and fetches whatever it thinks is the most relevant for a particular question. We have a parameter top n defaulting to 3, meaning that we will fetch 3 most relevant sources unless otherwise specified. You can either make it smaller or you can make it bigger. It depends on your data and your quality requirements and the size of the context of your LLM, many things. So it's a pretty interesting optimization problem at which number of sources you should arrive. But the common practice is to keep it around 3. And then get answer. So in get answer is where you take the retrieved information and you take the query and you give it to the LLM. So here it's as simple as you are telling your LLM you're a helpful chat assistant who will be provided text information for you to refer to in response. And like I said, you give it question and context. And we are using GPT-35 Turbo. Obviously, it can be different LLM, but it's smart enough to tackle the kind of question we have here. So here's a real example. How do elephants communicate over long distances? And did I run this? Let's see. Let me run this function. So if I execute this block of code, this should trigger a query to Azure AI Search and return me context and sources. And then, so this is cached response, which I previously generated. Let's rerun this again. We expect it to explain us how elephants communicate over long distances. So yeah, here you go. It used whatever we gave to it to answer. Now let me try a little bit more interactive version, so that you can, like, instead of coding, you can dynamically ask questions directly within your notebook. So let's repeat this and see what happens. Yeah, so and let's ask about elephants here. Yeah, my browser is a little overloaded. So how elephants communicate. Yeah, so we basically have built a simple RAG in just a few minutes, right? From having a data set in the beginning to pushing it inside a vector database and to being able to query it. So yay, first goal accomplished.
Pretty amazing. And especially since you're doing it all like in the notebook. So it sounds like anything RAG and Gen AI related, as long as you can work with the notebook and you know the inner workings of having the chunk embed and then retrieve, you can pretty much do anything via the notebooks, correct?
Yep. That's really awesome part of it. And the amount of what you can do is really sky's the limit. So the rest of the talk you will see how much more advanced we can get with that.
Quick questions for you. One of them is, it's great to be able to do it in the notebook and ask questions against your data as the actual data scientist or developer. Is there an easy way to like expose being able to prompt against the data in Fabric? So that's one question. And then the second is, can you do this with the structured data as well, or is this purely just working off of the unstructured data in a lakehouse?
Yeah. So yes and yes. short answers. In terms of working, let me start with the second one. In terms of working with structured data, Fabric already has a pre-built component called AI skill. It currently works on SQL. Stay tuned for what's coming up next. There are some awesome updates in the baking, but it specifically is designed for you to query the structured table data and get the answer in human-friendly form. You can ask in natural language. Behind the scene, AI skill generates query to SQL, then looks at the returned results and comprehends it and gives you back the answer, and that also gives you back the data, right? It's available both in the form of user-friendly like interface of like web UI, no code UI, I mean, and also it's available in the form of Python interfaces in the notebook, which naturally leads to the second part of the question, right? Like it can also be part of the RAG. Like I can, for example, have a knowledge base, which is partially unstructured data of some articles and partially structured data in SQL or something else. And then it together, we can put this behind some functional interface and return results from a hybrid RAG. I think we'll likely have samples of such systems sometime soon, but currently we have separate samples of AI skill and separate samples of RAG. Okay. Did I answer?
Any questions?
And I'm about to start the second part. So you can also think about more questions while I'm presenting.
You were so good at explaining all the different pieces. Nobody has questions.
Or maybe people just lost interest.
No, I don't think people lost interest. I think people are still awake. Can we get some like clapping or something on the other end? Awesome. Okay, rock on. See, you've got your fans. Everybody loves the octopus.
All right. Okay, so second part of the talk. You may ask, like, hey, Alexandra, like, why actually Fabric, right? Like, I could do your notebook on my local machine. And the answer is in, like, very simple, quick form. Picture is worth 1,000 words, as we all know. Because we don't want to accomplish something like in this photo, right? I unfortunately don't know who to give credit for this awesome picture. I got it like as a meme from a colleague in the chat, but I really loved it. I think it encapsulates the idea greatly. If you just take your data and you just stuff AI into it, which is what naive RAG is, it's unlikely that you get production quality result. You will get something. So something will get pumped and something will get answered, but the chances that it is useful for you are not very big, right? Because production problems are tough and we need more sophisticated processing on the data before it becomes good enough for AI to consume. And this is what the second part is about. So in the second part, we'll cover the importance of HyDE. We'll talk about how to clean data with the help of GenAI. We'll talk about hypothetical document embeddings, which you probably have heard about. And very important one, evaluation and optimization, without which real engineering of RAG is impossible. So exploratory data analysis, right? It's kind of like always taken for granted in classical ML that you start to work on your ML problem with like looking at your nulls and looking at like graph of your numeric values. Are there anomalies or not? But this does not necessarily happen when you work with unstructured data. And this is wrong. Like this, with unstructured data, it is even more important to do EDA at scale because you don't know what your data brings and how to work with that. And this is where Fabric is important, because this is where, for one thing, you have the ability to work at such scale which would not be possible on your dev machine. And for the other, you can repeat this. You can do this on a regular basis. Data which powers your RAG, it is rarely stale. Most of the time it will be changing. The terminology for this is called data drift. And so in order to make sure that like whatever your design and parameters are still good, you need to make sure that there are no major changes in how your data looks. But of course it is more important to do most important to do in the beginning, but also important to repeat. What are you looking for in EDA of your knowledge pieces? First of all, obviously the length, right? When you work with a language model of a specific size, does your typical article fit this context window? It also needs to fit the whatever prompt you have for the model and user questions. So take all of this in mind, and you also bring like we discussed, usually not just one but 3 or 5 sources of truth. So all of that has to fit the window. And I want to emphasize this because currently like sizes of language models are big, but I expect that small language models are gonna become more and more of a common thing. And this, even though like it's not that important these days, size will become more important soon. What about anomalous data? I've encountered cases where knowledge articles appear as empty. For example, it happens because the whole article is just an image or some infographics, right? And if you work with only text modality in your RAG, this is a problem. You need to know how to handle this case. You need to potentially work with the content authors to give you some equivalent or highlight that this is not in scope of the RAG. You might have PII, which probably should not be exposed. And the goodness is with GenAI, you can anonymize your data pretty easily. There are cheaper ways, like Spacey library from a few years ago can do depersonalization of text pretty well. So that's not the only way, but that's one of the ways, and that's a pretty easy one. You may want to check the quality of your data, like with the help of GenAI prompt, you may find pieces of the data that are considered expired. Like if there is anywhere in the text that says like this rule will be deprecated as of like 2023 and the article is still there, you may use GenAI to identify it among like thousands of articles. So these are quite convenient perks of processing data at scale in this way. And then in some RAGs, there is redundancy. like say you can expect some pieces to be covered in more than one article. A good example of that would be technical documentation. It aims for non-redundancy, but as we all know, like there is some level of redundancy always. So it may be that like you get an article returned which is not listed as the right source in your evaluation benchmark, but it actually covers the facts that you need. And how do you handle this case? So all of these things, they can be covered in exploratory data analysis, and that's a very interesting part of working with the data. So here I just give an example of a simple, quick statistical analysis. We're looking to evaluate how long are articles in the knowledge base. And we see here that the majority of articles are pretty small, probably 95%, if I recall correctly, are less than 3,000 characters, and there are a few outliers which go above 5,000. But the way to read it, we probably don't need chunking for such knowledge base. What tool did you use to ingest the documents in this example? And is it good at separating text from graphs from, say, PDF document? So to ingest documents, we did not use the tool, we just used the code, right? So we first put the knowledge sources in shared storage. Like in this example, it was Parquet files in Fabric Lakehouse, but in general, it could be, for example, HTML articles, and yeah, how to separate text from graph and PDF documents. One of the examples of the project that comes to mind is like our agreement from the very beginning was we are only using text modality, and this EDA is actually how I discovered that there were like 2 or 3 articles that they had which looked as if they're empty because they just contained image data. So we brought it up to them and said like, hey, we cannot do anything with these articles unless you expand it to text modality. But in general, you just can add a layer of preprocessing. Like you can put a layer that converts image to text representation or applies OCR to PDF. And we do have also examples of dealing with PDF. So PDF is converted to text, and then we work with text. I can give links to the repo samples if it helps. Yeah. So basically, it's like you align everything to the same format with appropriate adapter, and adapter is usually a Python library or maybe some API. So cleaning data, I'm a data science freak, and like people think data scientists hate cleaning data. I'm actually loving it because it's so much fun.
You're lying. I don't believe it.
No, I'm true. You can ask people who work with me. Like I always love to like take this part of the project because like there is so much fun. Like you don't realize how much fun it is.
I'm impressed.
Also, unless like it's you get your hands dirty is when it gets a real production project. Otherwise, you cannot really optimize. So, what kind of cleaning you can do with Gen AI, right? Gen AI is fantastic. Like it, I already mentioned remove PII, which is a big production problem, but that's just like tip of the iceberg. You can fix jargon, right? Like say your knowledge base is not necessarily based on documentation which is written by, you know, specially trained technical writers, for example, or journalists. It may be based on forum of people just conversing in their like conversational style. For example, a project which I worked in Berkeley a few years ago, before GPT era, at the time of BERT dominance, if you remember that, was summarization of instructional videos. So we literally were taking transcripts of videos about like how you color your floors with like I don't know how you do gardening, or how you can trim your skirt, this kind of things, right? And this is like people with all kinds of like accents recording those little videos, and then automatic recognition converting it into a transcript. So all kinds of noise there, and you want to clean it, summarize it in the sense of cleaning it. So this is also what Gen AI can do. Go from like unstructured, noisy text to good structured. And structured can be in the sense of like well written, or structured can be in technical sense, like being a JSON. So you can convert, say, conversational piece into JSON, where it will contain predefined elements of question, answer, as many as they are in the block of text. Or you can convert input JSON in one schema to input JSON in another schema. Gen AI is also great at that. You can do a summary, which can help with discoverability of your knowledge articles. And my favorite piece is hypothetical documents embedding. So like this is my secret sauce for getting a strong retrieval performance. When we work with texts that do not have very good annotation. So what hypothetical document embedding is about is literally going from a text that covers some topic to questions which people may be asking, by questions by which this text may need to be discovered. So let's get back to the metaphor of like we're building some knowledge base to help employee navigate their internal company resources. So say you have an article which explains how you submit a business trip report. Article would be something like this. You go to HTTP blah, 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 blah. You click submit business trip report. Then you find the field where you put expenses, you upload your invoices, you put your manager's name, you press red button to submit, or you press blue button to save, or you press like yellow button to erase and start from scratch. So there is like, in what I described, nobody will be searching by red button, yellow button, and that kind of stuff, right? Nobody will be searching by press. This is all in terms of like discoverability of this article. This is all irrelevant noise. What people will be looking for is like how I submit business report, how I submit travel report, how do I like, do I need to put invoices, right? These are potential questions. So what you do is you tell your Gen AI, here is my chunk of text. Be creative and think of potential questions by which people should be navigating towards that article. And you, instead of, or in addition to, or instead, that's the question. But usually the thing which to work best for us. Instead of embedding the actual raw text with all those like red and green button and portal names, which nobody will be searching by, right? You embed the questions. And then when people are searching for some topics, the vector DB will be looking for match between user question and the set of hypothetical user questions which GenAI came up with. And the chances that the right article will be retrieved, they get much higher. So yeah, this is one of my favorite hacks for getting good results of RAG. And you might think it adds cost, but this is actually the opposite. The cost is amortized, like you are doing it at one-off basis. You literally just need to do it once for every article, unless the article changes. And then you get a really, really immense boost in terms of accuracy. Okay, so now that we have talked about building basic RAG and we've discussed of preprocessing, the big question is like, how good did we get, right? And this is something which you need to also evaluate, not just one-off, but you need to evaluate regularly. Why? Because as we discussed, the underlying data is changing. And you need to establish a system that includes benchmark of questions and answers and pointers to the sources of truth. And you need to establish a set of metrics that will help you identify problematic areas in the system and also see how you progress or regress with the performance in time. So the key important part that I want you to take away from this slide is the system has two important points that need to be measured. The first part is the retriever part. So we have index of document and the retriever that talks to this piece. And after this is complete, this gives us an opportunity to check whether we have retrieved something of relevance. So you usually want to get as close to 100% on the benchmark as possible, because the rest of your system will only work as well as your first part works. In the second part of the system, you get the context, give it to the LLM, you give the prompt, you give the query, and you expect that LLM will spit out like a summarized, polished version of what the user asked it about based on the prefetched context. And so if we didn't fetch good documents from the vector DB, then we're already screwed. Like even the best LLM won't perform well unless it happens to be and very good in this particular domain, which is better to not rely upon because it's also a path to hallucination. So we really do want to achieve results that are grounded on whatever data we give to the system. And this is slightly simplified picture, by the way. There is also check-in number 0. So if you remember in the first notebook, I was showing the point where I demonstrated that all of the chunks were successfully ingested and there were no failures, right? So you could also imagine check-in number 0 between index of the document and ingestion, because we want to make sure that all all of the data which we think should be in the knowledge base, it's actually already there. Because again, if we go back, if retriever goes to the index of document and index of document is not complete, it won't be able to give us 100% retrieval accuracy. So the idea here is to break down the RAG into slices and catch issues, isolate them to the part where they happen. I think it is very important to bring up and emphasize, because I've seen in many cases people just focus on the last part, right? Just look at the question and answer and ignore this middle part of retrieval score. And this is bad because retrieval score is also the much easier and much more reliable. It's deterministic. Speaking of
quick question on that. Are you using F1 scores as your retrieval score or something different?
Great question. I use top-N retrieval. This is, if you like had some background in search engine, that's a familiar metric. I think it works here very well. It aligns with the design of RAGs. And so the idea is like, is the ground source of truth, which is pointed out in your benchmark, within top N of your result. Can be fetched as first, second, or third, for example, for top 3. In this case, we consider it 100%, and if not, it's 0. And then it's aggregated over the whole benchmark, and we recommend the benchmark to be about 100 question and answer pairs, because it is conceivable for a human, but large enough to get some trends and not be too sensitive to like random fluctuations in the performance. But we look at F1 as well for questions and answers. For answers, I mean, yeah. So the good one about F1 is that it's deterministic, like rouge and blue and embedding distance. So it's good to have something stable. But also another powerful part is AI-assisted metrics, where AI can act as a judge and evaluate the quality of your answers in a similar way as human would. And it's good to also break it into categories, like you typically look at fluency, less important for current state-of-the-art models because they are fluent in English, at least not all languages yet, unfortunately, but in many languages their fluency is close to native speaker. So for the sake of like reducing the number of metrics to monitor, we usually limit it to 2 or 3. Similarity, groundedness, and relevance happen to be the most important. And then there is an important aspect is you want your judge to be at least the same or better level of model as the model that actually generates your answers. Ideally, better if you can afford it in terms of cost. And super important is to monitor your results across experience, because by itself, having a similarity of like 3.2, it doesn't tell you much. But if your similarity has changed from like 3 to 3.5 as a result of some change in the system, this is a good sign. Also, if it stayed the same while other metrics improve, this is a good sign. But the point here is that these metrics make the most sense when you look at them in dynamics. And this example is where we introduced the hypothetical document embeddings, and you can see what huge jump, what was accomplished in top 3 retrieval score after this was done. So, yeah. And unless there are questions, we are up for the second demo.
Questions, comments, maybe even concerns? Yes, Taylor.
Sorry, I was trying to clap. But
Oh,
yes,
okay.
no, very, very interesting. I am coming up with a question though.
Okay. All right. So I'll jump to one more notebook. Hopefully. Yeah. So this notebook is where I actually implement this concept of evaluation, which I told you about. So the question which I've been getting to is the frameworks for evaluation. Like, I personally don't see very much value. I do like to have evaluation as part of the coding solution because it takes not much to implement and you have full control over it. I'm skipping the beginning of the notebook because practically it's what we already discussed, right? We are just loading the data here and defining the retriever component and the component that responds. So first you want to start with just like smoke test. Does your system work end to end? And like in this piece of code, that's what I'm doing. I'm sending question, how many suborders are turtles divided into? This is an example of question from this benchmark on the data set from CMU. And then I run get answer, and then I print the answer. So yes, end to end, I got my rat to do what I want. Okay. And I know that it's indeed 3 in the Wikipedia article. So then I establish metric. First, I establish this top N score, and this is a really easy metric to define. It's a function that returns 1 if the retrieved sources contain target source. Target source is defined in the benchmark by either human or AI. We can, if time permits, we can come back to how we establish the benchmark. But basically, in this case, I know that turtles are in this article, and so I specify this as the ground truth. And then I run the function get retrieval score on inputs, which include this like ground truth and retrieved sources. Retrieved sources is what came out of get context source function in the previous cell. And as we can see, the score is 1 because indeed set 1 A9 article is there. By the way, you can see it there twice. Can somebody guess why? Okay, I can answer because it was chunked, right? So we basically got 2 chunks, both from the article about turtles. And so this is a bigger definition of groundedness metrics. We did not invent the metric, we just took the prompt from Azure AI Studio documentation. And it's pretty good to do so because then it is defined in a standard fashion as like other people look at it. The only piece which I added was don't explain the reasoning. The answer should include only number 1, 2, 3, 4, and 5. The problem is sometimes like humans LLM tries to go an extra mile or questions itself, and even though you tell it like, hey, give me like numerical score for the for some evaluation, it can come back to you with very verbal explanation. It can say something like, yeah, I evaluate the groundedness as 3 because for one thing it is like actually overlapping with the source, but however, it also has some additional stuff. So that's not what we want. We wanted to give out just numbers of 1, 2, 3, 4, 5, which approximate how well the answer is based on the given context. In a similar way, we define relevance metric here. The parameters are context, question, and answer. And we also define similarity metric here. The parameters are question, ground, truth, and answer. We don't give context here, right? Because we want it to really focus on how close ground truth. Like whatever answer is the model answer that our subject matter gave in the benchmark is close to whatever the model generated for us. And we explain like how 1, 2, 3, 4, and 5 should look. Okay, and now let's test the metric. So first we test relevance, and it's kind of funny. It gives out 2. 2 means the relevance is bad. And the question, if you remember, was like how many how many species turtles are broken into. The answer was 3, and from the perspective of LLM, this is not a relevant answer, which I think is pretty funny. But when it looks at similarity of 3 and 3, it indeed correctly says like, yes, the answer is similar to model answer. So there is a bit of issue with how reliable those scores are. Most of the time they're good, but as humans, LLMs sometimes give different score to exactly the same answer, and as humans, they sometimes are wrong. But on the scale of large number of questions and answers, this becomes less of an issue. So when you have 100 of questions and answers, for the most part, it will do well. So what I'm doing here is I'm defining, like I'm wrapping those functions into user-defined functions. Oh, we already discussed in previous notebooks that user-defined functions allows us to run the functions at scale on big data. And so because we have a bunch of questions, we want this to be at scale. So retrieval score is what we start with, and we do see that we got perfect retrieval. Awesome. So let's see how the responses look after that. So retrieval score 1 is good, but groundedness 1 is not so good. So for basically other metrics, it's 1 to 5, and higher is better. So we get very high similarity. There are some issues. And in our experience, the questions which are worth looking into in the first place are those where scores are less than 3. So 1 and 2 on at least one of the metrics is a signal for human to be involved and see what's going on. Sometimes it may be red herring, sometimes it may be a legit problem, like maybe your data source is not easily discoverable. Sometimes the problem is the question itself. You can see what is here, something about elephant answer and generated answer. So here we can see that actually it did well. The brevity was probably not on the side of the model here, because the model answer is longer. But in other cases, it works pretty well. Like this answer got all 5s. And to make it easier to evaluate things at scale, how you're doing, it's also good to build some visualization, which you can use Power BI for. But because I'm a data scientist, I would rather shoot myself in the foot and do Matplotlib inside the notebook itself. And we can see that we are overall doing pretty bad in terms of relevance and similarity. And like there are just a couple of anomalies which we can investigate and see if they're like false positives, false negatives. So this is the end of the.
A quick question, Alexandra. And I thought this was a good one. Can LLM temperature affect RAG scores, or are those not related? And my guess is he's talking about temperature based on like, randomness.
Yeah, that's also a good one. We usually keep temperature low because for our cases, being as close to facts as possible is important. Like that's the by design of RAG, you don't want LLM to be very creative here, right? If you are doing a system to like write poems and something of this sort, you want creativity, but we keep it the temperature as low as possible. That being said, even the very lowest temperature, it does not give you absolute determinism. You still will get like fluctuations in both LLM as a judge setting and the setting of it to produce responses to the user. Like it may be that like 4 times out of 5 it will spit out the good response based on the same retrieved sources, and 1 time out of 5 it will produce some rubbish. It just happens.
Is there like a default temperature you use? Like, I think I've seen 0.07 used a lot.
I'm trying to find it. I can follow up with that. I don't see it somehow here. Yeah, we usually use default temperature. But yeah, sorry, I just don't want to do hand waving. I want to find the number. But what I want to double click here is, unlike in the first notebook, for the sake of demonstration, I'm using a custom GPT, and it's also different GPT. It's 432K, and like I use different models in general. Like I could use the same name here, but I wanted to demonstrate to you that like I could use like GPT-3 for the model, and I could use GPT-4 for the metrics. But I chose to use GPT-432K for both. I could put GPT-01, for example, if I wanted. But that's all the possibilities that you get. Okay. So we have third part left, unless there are questions.
Questions, comments? Getting close. Are we rounding out to the third base?
Yeah. So third part is the funnest, I think.
Cool.
We get to it. So yeah, like I mentioned, third part is sneak peek of what you might learn at FabCon if you go to our talk. knowledge at your fingertips, a blueprint for building data-driven AI agents. So here is the agenda. First, we'll talk about multi-agent framework using Azure OpenAI Assistance API for pluggable architecture with Cosmos DB and Bing for RAG. Then preprocessing of Teams messages for the knowledge base. Then how to generate FAQ to identify, let's get back to it later, and then how to evaluate your RAG in the more advanced case when your sources are dynamically changing or you have multiple sources of truth. Okay, so this is a schema of RAG in more detail. It is inspired by an article which I like very much. I highly recommend this as a reading. The reference is here, but basically, like, this is front end. This is where everything starts. This is where query gets to the system. There is a component called query rewriter, which is highly recommended pattern to implement as part of your RAG when you're dealing with more or less sophisticated scenarios. Then you have semantic decider, which can decide where to fetch the information from. And like we discussed earlier, it can be either static database or it can be an API to some system that is an adapter to other documentation, which you did not preprocess as part of your knowledge base population. Then you take this retrieved context, you give it to LLM formats it, spits out a response, and this goes to the user. So this is how like generalized RAG looks. And this is an example of more advanced RAG for scenario which currently we are tackling internally to help our bigger team, the customer advisory team, deal with questions about the products being developed in Azure Data Org. As you can imagine, there are thousands of people who work with the field in Microsoft, and they have questions about like when certain feature is coming out, is this supported or not, and like is there like workaround for a particular like thing which is maybe not supported yet. So all of these things which used to require a subject matter expert, because for one thing, there is a lot of documentation for people to grasp, and for the other, some things may still be in works, and only subject matter expert would know like when it's coming out, right? So there is such discussion internally, and there is a limited number of subject matter experts who don't scale enough to support the growing need of people to answer them. So naturally, the idea came up to develop a virtual assistant that would help to address the majority of such questions automatically. And we called this CAT AI Assistant after customer advisory team name. And there are like it, as you can see, it pretty much one-to-one maps to the principal schema, which I covered in previous slide. We have preprocessing part, the fabric part that uses Teams messages previously stored in this chat, because many questions are coming up again, even though maybe a subject matter expert answered them several days or weeks ago. somebody new to the channel might be asking them. So instead of bothering an expert, we can refer the user back to that previous conversation. And another benefit of that is we can generate analytics from the history of this chat. For example, we can identify which questions are asked the most, and potentially it means that there is a gap in the documentation, or maybe something that can be explained cleaner, in more approachable way, and people will be asking about this less. So anyways, the information again is broken down into chunks as needed. In this case, we are using Azure Cosmos DB as the vector database, and also API that provides additional information is Bing. We are limiting Bing search to just Microsoft Online documentation. And in this way, we don't need to have pipeline and update it regularly and put it into Azure Cosmos DB. It's just always there, the freshest and the most relevant result. We can count on Bing to fetch it from the documentation. Okay, so the rest is similar to what we talked about today. Chat provides us the query and the history. Chat history, there was a question about it in the beginning of the discussion, right? It sometimes matters because people may refer to what is discussed before by it or they or whatever, right? So basically, chat history is the important context which might need to be used as part of the prompt, which was sent to LLM. And another fun part here is that instead of explicitly designing the query rewriter, the semantic decider, and response formatter components of the system, we rely on agentic tools, which are taking care of talking to Azure Cosmos DB, talking to Bing, and figuring out if whatever they acquired is sufficient to address what the user answered. If not, it can go back to Azure Cosmos DB with reformulated query from the user or reformulated query to the Bing. And then once it decides that there is enough information, it formats it according to the guidelines we give in the prompt and replies back to the user, and all of that is deployed within Teams. So this is like a real life case of how Gen AI is envisioned within Microsoft to improve our own productivity.
There's a lot there. I think a lot of people don't realize how much goes on underneath the covers because accuracy and responses are so important, especially in adoption. Like, look at all the pieces necessary to make sure that these responses are, are what we expect, right? And are natural. There's a lot.
There is a lot. And also, in order to make it reliable, we make sure to provide the user not just, the summary of what was discovered, but also links to the supporting sources. So the message that the user gets back from the bot contains the acknowledgement of the query, summary of whatever it uncovered in response, and links to sources and online documentation, as well as links to Teams messages in the chat, if such have been discovered that are relevant to their query. So the user can click and verify that yes, AI made sense of it. It is important because for example, currently it does not support image information, right? So in the rare cases where somebody is asking a question, if how to do such and such thing. AI may respond that like, I haven't found explicit answer to your question, but here is the link which is relevant. And the link would lead to the online page, which has this like picture of, say, architecture of how to integrate different pieces together. So in this case, user can see that information is actually there. AI just couldn't make sense of it. So yeah, there are some overlaps with Copilot. It's not in the scope of this talk to discuss in details why we went with a route of implementing it as a plugin with bot framework. The short version of it is that we have more control on the data and how it is presented. So this is like in the terms of stack of technology, this is a Teams plugin working over bot framework and the Azure OpenAI assistant toolset, like I said. But in spirit, it's very similar. Okay. Frequently asked questions. So this is, I think, super cool part. Before I started, I actually thought there must be something out there on great internet to just solve this problem already, and I didn't find anything. The FAQ generators, I didn't find. Maybe I didn't have luck, or maybe it doesn't exist. So if you ever came across something that like generates questions when you feed it some online discussion, I would be really curious to ask. But the only thing I found, some academic paper of a few years old before the general availability of GPT. And so yeah, I had to write it myself, and it was a lot of fun, and it ended up to work. So the process of how you go from, like, say, some online forum where people ask and answer questions to the most popular questions is represented in this slide. And it literally goes down to just like several lines of Python code, which I think is quite amazing, isn't it? Right? Like you go from thousands of questions to like condensed gist of the most popular themes in a few lines of Python code and in very reasonable time. So what is involved? First, you apply pre-processing and you do data cleaning. That's what we discussed in the second part of the talk. In this case, data cleaning involves segmentation of posts into questions and contexts. As part of EDA, I discovered that each post in that channel for which we developed this automation, on average contains 2 questions, not one, but people usually ask at least 2 things. And in extreme cases, it may go as high as like 10 questions because they're like, oh, when is something released? And by the way, why does this part works this way and not that way? And also I have specific question from like this customer, and they are asking how they should configure like that part. And all of that is just one post. So if you try to find a frequently asked question like on this kind of post, this will be very contaminated results because it's multiple questions asked than one. So you first break it down, then, like we already know, we do calculation of embedding for each individual question, potentially context for this question, and then you do clustering. And then for each of identified clusters, you give results again to LLM, and you tell like, hey, can you summarize? Can you go from like this, like say several dozen questions and try to compress it into 1 or 2 questions? The clustering part, that gave me a lot of fun. So I thought about different clustering algorithms, and I ended up with hierarchical agglomerative clustering, because in this period, it was the closest to what I wanted. With hierarchical agglomerative clustering, unlike with other algorithms, you don't have to have pre-existing knowledge of how many clusters you have. And in this problem, I don't know in advance how many like areas the questions can be grouped into. I can just experimentally try. So what I can do though is that I want to group together the closest questions first, and then I basically build a tree with as many levels as I have like leaves, and then I can cut this tree at the level where like I think would be a reasonable number of clusters, and then I look at what's within each cluster, and if it looks like grouped, reasonably grouped, I can stick to this number of clusters, or I can go higher or lower to like be more specific or more high level. So this kind of clustering gives me the best ability. This is like actual visualization from 1,000 of processed posts within this chat, and it gives you an example, right? So there are some like very popular themes, and there are some less popular themes, but they're very distinct, and it's really impressive how good embeddings together with Gen AI is at focusing on the gist. Like, say, if there are questions regarding replication, they may come from different geographies, but it focuses on isolating questions about replication rather than focusing on grouping questions about like things in Europe or things in Australia and Asia Pacific regions, right? So I think this is really fascinating how quickly these days we can go from huge unstructured blocks of information to concrete actionable insights. That being said, AI is funny, right? So at some point, the pipeline for doing it broke, and the error we saw was like it exceeded the window of LLM, and we were like, how is that even possible? Turns out the AI just got stuck in the loop, and it hallucinated non-existing answers, as if like there were 100 answers, people saying exactly the same thing to each other, like, I agree with previous replies, it is important to consider scalability, security, you know, this traditional like bingo of technical terms. So it's just really, really funny, something you may not be prepared for, but something which is very easy to work around once you know that may happen. And that's the only time when it happened, I think one time out of thousands of processed responses. So you just need to be prepared to live with that. And yeah, I think we are at 7 p.m. I don't have hard stop, so I can cover additional 2-3 slides if people are fine with that. Yeah.
No time. You got this.
All right. So another important aspect with this project, which we were facing, was evaluation. Unlike the naive RAG, where the knowledge base is more stable and questions are also stable, and there is one source of truth, here we don't have all that, right? For one thing, documentation is not in our control. So let's say something that used to reside within a particular page in Bing, and that's where we put it in our question answer source of truth benchmark for testing. It invalidates the pointer to the source of truth. Another thing is there may be duplication, triplication by design, because we assume that like the majority of things which people ask about is covered in online documentation. Probably they just like couldn't find it at once, so they go to subject matter experts. Subject matter experts answered. Maybe they explicitly cited what's out there in the docs, or maybe they put it into their own wordings. But end of the day, what happens is question gets multiple sources of truth, right? So how do we deal with that? How do we deal with the fact that like top 3 is not as reliable anymore as it was with this like static world of Wikipedia snapshot and questions? So we go around this by designing a proxy metric with AI as a judge that evaluates how much whatever was fetched from either Bing or Teams history overlaps with the ground truth answer, right? So in the benchmark, we have some question, some model answer, which has been validated by a subject matter expert, and we have a source of truth. Source of truth might be either linked to Teams conversation or link to page in Microsoft Online. We don't trust this pointer very much anymore, but we do trust the expert's response. And so the new metric which we came up with, it's called retrieved context semantic coverage. I don't know if this is a perfect name, but it is meant to capture the idea that like how much of the answer that was given by the expert and is within whatever context we found in this run. And it's also interesting. I mentioned we are using this multi-agent framework with Azure OpenAI's assistant. We lose some control in this fashion, right? Everybody now is crazy about multi-agent system, but keep this in mind, right? Like when you have this like vanilla simple linear flow, you have control. You always retrieve the same thing when you search by certain query. Here, not the case anymore. Agent may decide to go just to Bing. If it found enough, it will not even go to Teams and it will spit out the answer. Or maybe the opposite, right? Like it tries Bing, it tries Teams, and only then it gives you some responses. And this may not necessarily include the pointer to the source of truth, which is in the benchmark. But with this metric, where we focus on whether the expert's answer is covered within whatever the agents fetched from Teams or from the internet with the help of Bing, we give it a 1. If it didn't fetch it, we give it a 0. If it's somewhere in the middle, like parts of the response are there and parts are not, we ask LLM to judge and give appropriate ratings. Okay, so yeah, this is it. This is not the whole project. This is just some exciting parts of it. If you want more come to our talk at FabCon, but I think the takeaway message from the third part is you can see how many components from Microsoft ecosystem, with the help of Fabric, are coming together. Like, we start with Teams, user asking some question in the Teams, and then it goes through the underlying infrastructure. It goes to potential sources, either in online documentation or maybe in SharePoint or maybe in other Teams conversations, and then it gets processed with the help of the LLMs, and then in conversational format it is returned back into Teams. And we also see some useful insights of what's going on in this forum through Power BI dashboard. So I think it is pretty awesome to see how, like, this is being unified and how the loop is closing. Oh my, so you probably didn't hear, but like, I had some music.
I heard that scared me for a second.
Yes. So yeah, this wasn't meant to be, but yeah, useful pointers. If you want to dive deeper on what I covered today, you could look into Fabric blogs. You could look into the code samples. You could look into Data Science at Microsoft blog, which covers how to generate a benchmark. Super important topic, which I wish I had time to cover, but maybe next time. But this is also where AI can be your best friend. And yeah, acknowledgements to the awesome team who it was possible to put all of this together. Applied AI group of engineers, and other Microsoft employees who have been working on this materials, including codes and text and presentation. So yeah, thank you.
Cool. Well, again, Alexandra, thank you. You can get to your evening now. Thank you again, everybody. Hope to see you all next month for our next Fabric user group. Sayonara.
All right.
Thank you.
Thank you.
Thank you.